Sometimes one wants to map coverage over a longer time, or you do not want to keep your phone awake while mapping. And in some situations there isn't an internet connection available for your phone and the app to use. Therefore, the most common way of mapping a gateway's coverage is by using a GPS tracker. A tracker has a GPS receiver on board. It can therefore determine its location by itself. The tracker then sends this location in the payload of the LoRa message. On the Things Stack console, one can send these coordinates along with the metadata of the message directly to TTN Mapper. Let's hook up a GPS shield to our Arduino. One would normally use the Arduino Maker GPS shield, but I do not have one of these. I'm using an old SparkFun GPS logger shield that is meant for the Arduino Uno. These two shields should work the same. Only the electrical connection will look less tidy with mine. Gonzalo Casas has made an example GPS tracker sketch for the Arduino Maker WAN. Go to his GitHub and download a zip. Extract it, then open the Maker WAN 03 GPS tracker example. Also have a read through the README which explains the electrical connections which are necessary between the GPS shield and the Arduino. Again, copy your keys from the console and paste them into the Arduino secrets.h file. Now I'm putting the box with the Arduino GPS shield and USB power bank outside so that the GPS can obtain a GPS fix. Let's look at the console to see if we are receiving messages. The payload is showing some hex values which we still need to convert to coordinates. Let's add a payload decoder. Gonzalo provides the appropriate one in the README. Copy it and click Save. Back on the Live Data tab, we will start seeing the decoded payload, which includes altitude, h-stop, latitude and longitude. To send this data to TTN Mapper, we need to add a webhook. In the left-hand menu, go to Integrations, Webhooks, and then choose Add Webhook at the top right. From the list of templates, choose TTN Mapper. In the Webhook ID field, type any name for this webhook, something like My TTN Mapper Webhook. A valid email address is required to identify who is providing this coverage data. If you are not sure your firmware is working correctly, or if you are mapping coverage from an unrealistic location like a weather balloon, provide an experiment name. Otherwise, leave the experiment empty. Click Create TTN Mapper Webhook. The steps we followed here can be used for any GPS tracker device. As long as the device is providing a latitude and longitude in its decoded payload, TTN Mapper can make use of this data. Everything is now in place for you to go on a range testing drive. Have another walk around the block. When you come back, we will analyze the data we have gathered using the TTN Mapper website.